Hi guys, I'm Rohan and I'm currently a rising junior at Fremont High School. So the starter project I made when I entered Blue Stamp was the Simon Says game. That was actually my second starter project. The first one went terribly wrong as I didn't know how to solder. But fortunately the starter projects helped me learn how to solder and put electrical components together, which overall helped me with my main project as I had to do that a lot. So my main project is an adjustable socket that attaches onto a ratchet. So the reason I made it is because to make the lives of the user easier, as they don't have to go through the hassle of finding the correct socket that'll fit on top of a nut or a bolt. And personally, I've faced this problem several times when I've been working on my car. So I wanted to make a product that make my life easier and people who face a similar problem. So parts-wise, my project is essentially a chuck mounted on top of a ratchet with 3D printed parts that I designed, and they hold everything together. And on the back, there's my whole electrical setup, and this is a DC motor, which acts like a chuck key, so that's what moves the jaws. And there are two buttons over here, which dictate whether the jaws will retract or enclose. So this project works so there's a PCB over here with an Arduino attached onto it, and that's what moves the motor, and with the help of a motor driver. So that does that, and I had to code how the motor will work, and I also had to code a step machine so the buttons would function over here. Sorry. And so mechanically, I had to create a couple of designs for these 3D printed parts on SolidWorks, and that was kind of tricky, but that's what's holding my whole project up together right now, all of these golden pieces over here. And a neat part of my project is I have a current sensor on my PCB. So what I can do with that is once my jaws tighten around a nut or a bolt, the motor will stop running so it doesn't break the chuck or the bolt. So the biggest challenge I faced with this project was my 3D printed parts. It was really hard to work with at the beginning, even though I ended up using a lot of them. So this is a metal chuck right now, but I started off using a plastic chuck. And with that, I learned that 3D printed parts don't move well together as they're plastic. So I spent a couple weeks sanding and filing, not a couple weeks, but so eventually I moved on to this metal chuck, which works really well. So another challenge I faced was these brackets. They're plastic, so they break fairly easily. So I had to create a pretty strong design. So that kind of connects to my modifications I plan on making in the future. So I'd like to make stronger brackets as they still break really easily. So I need to make them structurally stronger on CAD. So yeah, so my project works like this. So you plug it in, and then the two buttons on the side. So one of them you hold it, or you don't have to hold it, you press it and the jaws enclose. It's kind of hard to see. The other one you hold this button and the jaws retract. So Blue Stamp was really great, and I really enjoyed it. At the beginning, I kind of hated it. I did not enjoy waking up early. That was the only reason I didn't like it. I sort of regretted the morning session, but every day I enjoyed it more and more, and I actually started staying in the afternoon session too, when my project wasn't working. So it was really fun, and I'd like to thank Sky, Eduardo, Asher, and Brish for always guiding me and helping me and learning everything. So yeah, thank you guys, and thank you. Sure.
So you say that it stops because of the current sensor. So why use a current sensor and not another kind of sensor?
Well, when this tightens around something, it will feed a current. So it'll be able to sense when something is getting tight. So for example, if the motor is running and you stop the motor, if you pull up a serial monitor, it'll tell you what the current is. So it's really simple to hook this up and type in a current into your code and say, I don't want the motor to run above this current or under this current. So then once it senses that, it'll just stop running. So it's a really easy way to get it to stop the motor from running too much or too little. So yeah.
How do you sense the amount of current?
that's with the current sensor, and like I said, when this tightens around, it like feeds it the current. So like on your code, like there's like a serial monitor, right? And it'll give you like different values. So I have it set up to like tell me what the current is. So like that's I guess how it works. And then yeah.
So the motor itself tells you the current, or you have to put some circuitry, or?
Yeah. Well, it's like yeah. That's like what the current sensor does. Yeah. So yeah. That's like the whole purpose of that. So yeah. Alright. Well, thank you.